Hello, everyone. Welcome to the first session of the course offered by AI in Medicine and Medical Systems Society, which is the applications and introduction of artificial intelligence in healthcare. I am Nazila Ameli. I am a DDS and I have a master's in orthodontics, and I got my PhD about the applications of AI in the field of dentistry. And I'm currently working as a clinical assistant professor in the School of Dentistry at the University of Alberta. Today, I'm going to talk about some basic ideas about artificial intelligence and machine learning and some common terms that are applied to both of these concepts. And we will discuss different types of medical data that can be used in AI field. And we will wrap it up by a brief discussion about the benefits and challenges of integrating AI in medical field or healthcare. And during the next sessions, you will get familiar with the machine learning techniques and algorithms, deep learning algorithms, large language models, and how to read an AI paper and evaluate AI products and the applications of AI in medicine and their current research at the U of A. So before diving into the discussion, could you please scan this QR code? There are a few questions for you. We are going to answer the question just to get a better understanding of how much you are aware of AI and its application in medicine. Okay. So, okay. Okay, if you, if you have access, the first question is about when you hear the word AI, what's the first word that comes to your mind? And it's about data, it's about ChatGPT, ethics, knowledge, and many of you just mentioned about ChatGPT. I can see text, data, machine learning, robots, robotics, neural network. Yeah, there are lots of answers. Just quick, yeah. Okay. Convenience, data frame, unreliable. So someone is resisting. Okay, sounds good. And what about this? How familiar are you with AI? Let's see how many of you have heard about AI and its applications in healthcare, and how many know a lot. Okay. Okay. Okay, so it seems that all of you have have used AI so far. Some of you are using it in your research, and some of you have used tools like ChatGPT, not in your research, but it's almost used. So none of you have never heard of the healthcare or AI, so this is really great. So, and let's see the next question. And which area of healthcare do you think AI will impact the most? Is it about diagnostics and imaging? It's about personalized and predictive medicine, population health and epidemiology, drug discovery and development, or any other fields that you think it can affect the most? Okay, so most of you mentioned, oh, it's changing. Diagnostics and imaging first, ranked first. Personalized and predictive medicine is the second. And population health and epidemiology is the third one. And drug discovery and development is the fourth. So let's go to the next question. Do you think AI will replace the healthcare professionals in the future? Oh. Okay, most of you mentioned that maybe not, but only on some specific tasks. And one mentioned no, and one mentioned yes. So, and let's go to the next question. Which of these is not an example of AI? ChatGPT generating text, Google Maps suggesting routes, a traditional X-ray machine, and Netflix recommending movies. Okay. Okay, so almost all of you selected traditional X-ray machine. And there is one option showing Netflix recommending movies as not an example of AI. And let's go to the next question. And this is an open-ended question. What do you hope to learn most from this course? And some of you just answering through the chat. Okay, sounds good. Okay, so many different ideas, which is great. So we try to include at least most of these ideas in our course, and to meet your expectations. Okay, thanks. And I think this is the last question. How confident are you in explaining AI concepts to a patient or colleague right now? I mean, before starting the course. Okay. So most of you are slightly confident or not confident at all, which is fine. There are some of you who are moderately confident or feel very confident, which is great. Okay. And thank you so much for participating in this, short test. So we can figure out your expectations about the course and your level of knowledge about the AI and healthcare and its application, which is great. So let's start our topic, which is the introduction of AI in healthcare. Well, as you answered to one of the questions, artificial intelligence is almost involved in our daily life, and maybe we are not noticing this. It can be included in ChatGPT, which most of you mentioned about it, which is a tool that uses AI to generate and understand human language. It can be used in smartwatches to track our health. It can be used in some platforms like Netflix or Google Maps, which recommend us some movies, or which provide us with, the fastest route to the destination, or even the self-driving cars like Tesla. So this is not something that we are going to use just in health. It's something that is involved in our daily life. But what artificial intelligence is, in a very simple term or definition, artificial intelligence is machines or algorithms that can copy or mimic the human task or perform tasks that need human intelligence. And it is a very broad umbrella. There are other subsets that lie within the AI. One of them is machine learning, which is computers which learn from the data, from the experience. And we do have natural language processing, or NLP, which enables computers to understand and generate human language. So these are the main subsets of AI that can be defined. And if you want to take a quick look at the history of AI, the idea of creating computers that mimic human performance is not something new, and it goes back to the 1940s. In 1943, McCulloch and Pitts proposed the first model of artificial neurons, which is the foundation of neural networks that are currently used in many AI tasks. In 1950, Alan Turing introduced the Turing test, which answers a very, simple question, and that is, can machines' behavior be indistinguishable from the humans? In 1956, the term artificial intelligence was officially coined at the Dartmouth conference, and so this could be the introduction or the beginning of the AI in the history. And in 1980s, some expert systems like Dendral rise, and the process was to the objective was to introduce some programs to be able to solve problems using some rule-based logics. And a very big milestone was came in 1997, in which IBM's Deep Blue defeated chess champion Garry Kasparov. And so this idea came that sometimes machines can outperform humans in complex reasoning tasks. And since 2000s, with the advances in machine learning and neural networks, we can see very rapid evolving of machine learning and AI, and as we can see right now. And in the medical field, AI has also been very beneficial so far. It can be used in diagnosis, multiple tasks as a medicine. And the plan or objective is not to replace doctors. It is something that complements their task. It provides them with more information, with more details. So it helps them to make a better diagnosis and treatment planning. And so it improves the efficiency of the treatment care, and it can improve the patient outcome. We do have two different terms: artificial intelligence, which is the broad umbrella, and machine learning, which is a subset of artificial intelligence. And it is the task. It's machine learning is a very one of the most used AI techniques that is used today, and it's the ability of computers to learn from the data or from previous, so they can be trained on a specific data and that can be used for the future task. And there are two main types of machine learning. We do have another types, but these are the main ones that can be used in the healthcare, which are supervised and unsupervised machine learning. Does anyone have any idea about the difference between the supervised and unsupervised based on their names? What is the difference, or what does it refer to? What does supervised refer to, or unsupervised? Let me check the chats. See. Okay. Okay, someone mentioned that supervised means if you have known outcomes to train with. Okay. Anyone else? Okay, let's see what it refers to. Okay, supervised machine learning exactly means that we do have the data set and the data is known, and we do have the answers or examples. For example, imagine that we are going to give computer some information, some pictures about the spoons and knives. And on we provide the name of each of these, objects, which is labeled, which is called label, to the computer. And so the computer is provided with a lot of examples of spoons and knives. It looks like, if you want to just make in a real life example, could be if you want to teach a kid, for example, to see that this one is a spoon and this one is not, you are going to show the kid that this is a spoon and this is a knife, and you are going to name the objects. So after a while, when the kid is exposed to a lot of examples of knives and spoons, so after a time, he knows that this if a new object is provided to the kid, so this is a spoon and this is a knife. Exactly the same thing happens with the computer. It means that we provide the computer the known data and we give the computer the responses, the outcomes. So if in the future, for example, after a while, after the computer is trained, we provide a new image of any of these specific, objects, so the computer can make a guess. And based on the knowledge that it has gained through the training process, so it can name the object. So this is called supervised because we are supervising computer. We are guiding the computer to understand and learn from the data. And there are two specific types of supervised machine learning. The first one is classification, which deals with categories, different categories. For example, imagine that we have a bunch of radiographs and we want to know that if any of, to know which of them are normal or which of them are not normal. So we are going to train the computer by providing or feeding the computer with a bunch of radiographs, which are labeled as normal and abnormal. And after training the computer will be able to categorize these images. So if we provide the computer with a new radiograph, it can say that it belongs to the normal group or abnormal group. And there is another type of supervised machine learning, which is called regression. And this is a type that works with, this is to predict a numerical or continuous variable. For example, imagine that we are going to use computer to predict the blood pressure of the patient using some demographic information. We give the computer information about the age, the gender, any medical history, any medication that the patient uses. And so based on these variables, it can make a prediction on a continuous variable, like the blood pressure of the patient. And on the other hand, we do have unsupervised machine learning, which means that we give the computer our data, but we don't provide it with the correct answers. We just give the data, which looks something like this. We don't specify that which one is spoon and which one is knife. And this is the computer's responsibility to understand the pattern within the data. So it is not supervised and it is not guided. And most of the time, it is good for understanding hidden patterns. Sometimes, we as a clinician, not sure that's what we are looking for in the data that we do have. For example, the patient's clinical notes. And this is good for understanding some relationship between different, variables in the clinical notes and some hidden patterns that cannot be, that can be overlooked by human or not recognized by human. So again, we do have two major types of unsupervised machine learning. The first one is clustering, which means that it looks at the data, the computer looks at the data, and it tries to categorize and classify or group the data set into different classes and groups based on the similarity that it can find within the data. For example, imagine that we have a lot of, we have a lot of radiographs, for example, and we just feed them into the computer. So computer may try to classify these radiographs based on the pattern that it can see in the bone or based on the, any lesions that it can find in the radiograph. So it is going to classify. There is no label for these radiographs, but it just grouped them based on the similarity that it can find within the data set. And another one is about association, which is to understand the relationship between information that is provided to the computer. A good example would be just using clinical notes. We are using clinical notes. You know that it is the note that are written by the clinician during the examination, and it include medical history, demographic information, and any information about a patient. And you feed them to the computer. And computer, when it is reading the data, it finds that, for example, a person who is smoking has more, possibility of having gum disease. So it can find a kind of association between the smoking and gum disease. And so this is something that can be hidden, or even, a clinician cannot find it when reading the notes because it's a lot of text and it may be overlooked. So the computer can understand this association. So, and if a new patient comes in and is a smoker, the computer may predict that the patient is more susceptible to have gum diseases. So this is called association using unsupervised machine learning. And for you to have a better understanding on supervised versus unsupervised machine learning, here is a question. Imagine that you are asked to group the people in this class, and there is no predefined number of groups, and you are free to create as many as groups you like, and you can use any type of criteria. So what type of machine learning do you think it is? Is it a supervised one or unsupervised? Any thoughts?
Would this be unsupervised?
Unsupervised. Yes, unsupervised. It means that one of you may just group the people based on wearing glasses or not, okay, to different groups. One of you may do this by grouping girls versus boys. The other one may use other criteria. So this is something that it depends on the computer and the pattern it can find based on the similarity. You are not defining any specific criteria for the computer to do the grouping. So it tries to understand the similarities between the data set that is provided and then grouping them. So this is unsupervised machine learning. And on the other hand, we do have supervised. So imagine that we have classified the people in this class into two groups, medical students and non-medical students. And we have some criteria and features. We have defined the features and criteria. So we know that which, people need to be assigned to the group A and which people need to be assigned to group B. And so if we know the criteria and know the features, so if we want to assign this lady to any one of these groups, so we need to just take a look at the features and see if she has these features or not. For example, if she has attended to the she has attended the first session, or if she is, for example, wearing glasses. So it depends. There are different features that are defined. So we know the outcome, we define the labels, we define the features, and this is the task of the computer after learning, after dealing with a lot of data to understand based on the previous knowledge to assign this lady to any one of these groups. So it is something that is guided by us as a clinician or human, and which is called supervised machine learning. So any questions so far about these different types of machine learning, or any questions? Let me check the chat as well. Okay, yeah, they all provided the answers, which is correct. So this one is supervised and the previous one was unsupervised. Okay. And now let's see what we do have, as part of AI, because sometimes machine learning, which we talked about, supervised or unsupervised, it has some limitations. The first one is that when we need to train a computer, or when we need to do a machine learning task, supervised or unsupervised, we need a lot of data, and we need a large amount of data set of high quality. And this is not always the case, specifically when we are dealing with health information, because as you know, we are dealing with some sensitive information, and sometimes we don't have enough data, specifically when we are working on rare conditions. So in this case, machine learning or computer cannot be trained very well, and we cannot expect it to provide us with a high quality output. And also, sometimes, when it makes a diagnosis, or when it gives you a suggestion, there is no reason behind it. And sometimes we need the reason and justification for doing a task. It just gives you the diagnosis. It doesn't give you any reasoning or any cause and effect reasoning behind this. And the other limitation of machine learning is sometimes it could be biased, which again depends on the quality and the quantity of the data set. And so what comes here is called symbolic AI, which is an approach in AI in which we use some knowledge, some medical knowledge in the healthcare, in medical knowledge, and some rules and some justifications for understanding the relationship between within the data set. So machine learning was able to recognize patterns in the data set and it could be trained. But sometimes when we need to, have some reasonable reasons behind the task that we are doing, and sometimes when we do have information, some medical knowledge exists and it's strong, but we don't have enough data set to train a computer for doing the machine learning task, we focus on symbolic AI. And symbolic AI has the strengths of both machine learning, which is the pattern recognition, and the knowledge and medical knowledge. So it will provide us with more accurate results. And again, the indication of using the symbolic AI or knowledge-based AI is when we do have medical knowledge very strong and well-established, but we don't have enough data. So it's an example of using symbolic AI is for medical reasoning. For example, we know that if the patient has fever, cough, and fatigue, and if two of them exist, we can make a diagnosis influenza. So this is the way that symbolic AI works, and it provides something like this. So it looks like if something exists, then it is like this. So this is a rule-based method. It's not just finding the patterns using computers. It's some rules that are defined by experts and clinicians, and is used for providing the output, and it gives the explanation and it gives the reason, which is very important to improve the trustworthiness and accuracy of the model. And this is a knowledge graph, and this is a modern structure way of representing the symbolic AI. And you can see it can find the connection between medical entities. For example, for COVID-19, it shows that the symptoms are like this and the treatment would be like this, and it can be used for this study. And so it can find a connection between different medical entities. And this is a very good representation, so it can be very explainable. And it's very important in the medical field because sometimes we need the reasoning behind the decision or behind the recommendation, which is very important, at least to be able to explain for the patient. So this is another way of applying AI in medicine. It's not just always about machine learning techniques or neurons. But let's see how can AI help in healthcare or medicine. It can be used, these are the different applications of AI. It can be used for diagnosis, for making a diagnosis, for making some prediction, for providing personalized medicine for patients, for drug discovery and clinical decision support, which recommends it gives suggestions to the clinician about the treatment planning. However, the final decision is made by the clinician, and the collaboration between the clinician and the patient. So it is something that supports the clinician decision. It's not going to replace clinicians, at least for now. And if you want to go deeper to these applications, the first one, which is very important, is personalized medicine. It means that the computer analyzes a huge amount of data for the patients, from medical history, from demographic information, from lab data, from genetic makeup, anything, and it analyzes everything. So instead of suggesting one specific treatment plan for every patient, so it is going to personalize the treatment plan, which improves the patient outcome, because it takes into account many things about the patient, including lifestyle, including some personal information, which makes it more accurate and it improves the patient's outcome. And another contribution of AI in healthcare is helping in diagnosis and treatment planning, because it can analyze a huge amount of data again, and so it can provide more details to the clinician. It can detect some problems maybe more quickly, much faster. So it will be very helpful in early diagnosis of some conditions, and can suggest some treatment planning based on the findings that it provides. It can be applied for medical imaging. Sometimes there are some these medical images, when a human uses, they are seen by naked eye. We might overlook something, and the clinician, there might have some human errors. However, when using AI, it can just show us some patterns that we might overlook. So it can improve it can improve the diagnosis of the clinician, and not only for diagnosis or treatment planning. It can be used in the operation room as some assistants, robotic assistants in surgery. So providing the giving the surgeon this opportunity to do a mini invasive surgery, which means that less blood, less bleeding, a smaller incision area, and faster recovery for the patient. So this is another applications of AI in medical field. And we do have chatbots that make communication with the patient much easier. They are available 24 hours a day, 7 days a week, and they can give some information to the patient, some health education. They can even be used for booking appointments for the patient. They can be used for reminding patients about their medications. And specifically when we are working with patients who have chronic conditions, they can be used for just controlling the progress of the disease and let them know when to refer to the hospitals or medical clinics. So this is a very good way to make collaboration and connection with the patients, specifically those who are living in undeserved areas, don't have access to professional care. So it will be a very good method to just track their health. Also, AI techniques can be used in genomic medicine and to gene mapping and doing gene mapping and finding which is very great for making diagnosis of some diseases and providing the personalized treatment plan for the patients. And another aspect would be drug discovery, which is a very time-consuming and expensive field in the medicine. So AI models can just analyze the compounds of chemicals and make a prediction that which of these drugs would be more effective in treating a specific issue. Okay, any questions so far? Any comments? Before moving to the next main topic, which is about different types of data in healthcare that can be used for AI. Okay, let's chat. Okay. Let's move to the next slide, which is about the health data. So if we want to work with the AI system, like machine learning or any type of NLP, any type of AI model, we need the data for sure. So where do you think this data come from? Available databases, yeah. And what else? What could be the source of data? Anything else? These are the sources of data, and the health data. It could come from some genetic information from the patient itself. It could come from pharmacies, health agencies, hospitals, labs. So there are different sources of data for that contain health data, and we need to use all of this type of information or data for training our model or for AI applications. So let's see. If you want to categorize this data into two main types, we do have primary data sources, which means that the person, the clinician herself or himself, starts collecting from scratch. And on the other hand, we do have secondary data sources, which means that we request data from somewhere, and we do have the databases right now, and we just need to have access to those data sets. What do you think could be the advantages or disadvantages of any of this? In which one, or let me ask in another way, in which way do you think that we could have more control on the data set that we are working on? Yes, in primary, because we are collecting data based on the objective, our objective. So the main advantage of using primary data sources is that we do have control on the number of data that we need to collect and the quality of the data. However, it will be very time consuming and it will be more expensive, and it needs some ethics paperwork because you know that we are dealing with patients' information, which is very sensitive. So, and it needs a lot of pre-processing steps before feeding to the computer. However, when we use secondary data sources, it means that we are using data that is already collected and is available. We just need to request access, and after some, ethics approval, and we can have a large number of data in a faster way and a cheaper way. However, sometimes, we don't have any control on the quality of the data because the data was already collected for another purpose. So it might limit our access to what exactly we are looking for. So we need to just consider all the pros and cons of these two techniques. And based on the work that we are, based on the research or topic that we are working on, we can decide which way, fits our objectives better. And when we are working with data, and sometimes it is called big data because health information, as you saw, we collect information from different sources. It could come from hospitals, labs, genes, and it can be in very different ways. It could be text, it could be images, it could be audios, videos, anything. So this is called the big data, which means that we have millions of data. And if we want to describe the big data based on the, to have a better understanding of its quality, we do have 5 V's, and sometimes, we use 3 V's. The last 2 V's is sometimes not used, but just keep in mind that these 5 V's are used to describe the big data or data that comes from, most of the time for health issues like AHS information, that data come from hospital. The first one is about volume or amount of data. As we mentioned, we need a great amount of data for be able to train the computer, and the quantity of information and data is very important. The other one is about variety. We do have diverse data sets. We need to know if the data includes just text or clinical notes, for example. Is it going to include images or any radiographs from the patient? It is going to include videos or any gene information. So this is very important to know if the data set is diverse or not, because the type of technique or the type of AI technique that needs to deal with this data set is very important, and it depends on the type of data. We cannot use, for example, algorithms that are specifically defined for images to those that are specified for text. So this is very important to know the diversity of the data. Another aspect is about the velocity, which is the speed of data generation. If the data is generating so fast, like emergency sections, that we have a lot of data that is developed every day, so which is very important. So it will affect the volume of the data for sure. And we do have veracity, which is about the accuracy of data. It's not just always about the quantity of data. We need our data to be accurate, because if it's not accurate and the computer is trained on inaccurate data, the performance cannot be reliable. We need both the quantity and quality of the data to be high. And the last one is about the value. So we do have high quality data, we do have enough data, but maybe we are working, or our objective is something that this type of data is not helpful. It is not worth it. So for example, you are working on a specific disease, and you want to work on a specific disease, and you have a lot of CT images and with high quality, but this disease is something that cannot be detected on CT images. So you need to understand if this type of data, even if it is enough in terms of quantity, and even if it is high quality, is it worth it to use for understanding or detecting that specific objective or not? So these are the 5 V's that we need to consider when we are dealing with big data. And here is another way to classify health data or health information. The first one is called structured, which means that we do have data set in a structured format. It is well organized. It could be like some Excel sheet. It could be presented as in a table. So it means that it can be easily understood by different people or by computer, or it can be easily shared between information system, and it includes some information about age, gender. It looks like a chart, so it's very well structured, and it doesn't need that much pre-processing steps before feeding to computer. And on the other hand, we do have unstructured data set, which is not well organized, and it needs a lot of pre-processing steps before feeding to the computer. And for sure, it's difficult to share between different organizations, and it can include radiographs like X-rays and CBCTs, charting notes or clinical notes that are written by the clinician during examination. So there's no specific format in this type of data set, and we need to prepare them before feeding them into the computer. And another way to classify the healthcare data is this way, using quantitative versus qualitative. Quantitative refers to the numerical information, including age or blood pressure of the patient and weight. And on the other hand, we do have qualitative information, which look like text. They're non-numerical, and most of the time they are used for describing the patient's, condition, medical history. And so, those qualitative information might be a little bit challenging for the computer to understand, and it needs some pre-processing steps. So this one is much easier, understandable, and transferable between health information systems. However, we need to work on qualitative information more before feeding them into the computer. For example, a part of note may look like this. At 5:30, Mr. Smith presents with sharp headache. So, and so on. So this is most of the time text that might include numbers, but it's not, in nature numerical. Any questions so far? In the chat? Yeah. Let me see. Oh, the question is that, do we need all these for it to be considered big data? No. Big data is by definition means that a lot of, millions of data that are provided by different agencies. But what is important when we are working with big data, and specifically when we want to apply AI to big data, is that we consider all of this. The objective is very important for us, but these are the things that describe it, but it's not, we don't have to have all of these V's in a very high quality to say that this is the big data. Big data exists, but the quality of the big data or the description of the big data is it is described by these 5 B's. So we can say that this big data is of high quality, of high quantity, but it doesn't mean that a big data necessarily need to have all of these conditions or criteria to be considered as big data. And another question is that, do medical professionals, researchers, receive big data as clean and immediately usable? Of course not. There are some processes that we need to go through. Excuse me. And we can ask, for example, if you want to have access to AHS information, we need to go through some ethics approval, and we need the data to be anonymized for our use. And the data custodian just first anonymizes the data and then shares the information with us. And it depends on the, it depends. Sometimes some information are structured, as I mentioned, so it looks cleaner. So it looks like in tables, everything is provided, and sometimes it depends on the type. If we are looking for some clinical notes, they are not clean, they are unstructured, and we need to do the cleaning and to remove any repetition, any incomplete data if we want to do the analysis, but they are not always clean, and it depends on their types, if they are structured or not. And immediately usable, it depends. What do you mean by immediately? If you mean you need to go through ethics process to have access to those data, and when you do all of the tasks, then you could have access to the information. And another question is about, do electronic medical records have a structured or unstructured data? Anyone knows the answer? Electronic medical records. This is the topic of our next few slides, but yeah, let's see, what do you think? Someone says should be a structure, another one says both. And anyone from first people here? What do you think? What does EMR include? Is it a structured data or unstructured? Or both? Okay, both. We have one both here. What, some money gets spent? Oh. Yeah. Most of them are saying both. On the Zoom, people on the Zoom, some of them are saying structured, and let's see what do they look like? Electronic medical records, which is the next topic. So these are the type of data, examples of different types of data in medicine. We are going to talk about electronic medical records and somehow about medical images. Let's see. So, well, electronic medical records or EMR, and the key idea of introducing electronic medical records was to have something as centralized and standardized health records. And back in 1980s, it was found that fewer than 20% of family physicians in the US were using computers in their office, and they used handwritten, everything written manually. So it was something very time consuming and very prone to errors. And then by introduction of digitalization in healthcare, there are many people, many physicians that are currently using EMR in their clinic. So it's much faster, it's more efficient, and it's more time saving. But these are the type of information that EMR include. So you can see we do have some lab results, we do have some demographic information, we do have the medications used by the patient, clinical notes, any charts and any interpretation and records of the images. So what do you think? Is it structured or unstructured? These are all the information that can be found in EMR. So based on this picture, what do you think? Any ideas? Has any one of you changed his mind? Okay, someone said both. Someone said patient data. So based on the information that we already have, so it's a combination of structured and unstructured information. So it can include clinical notes, which is something unstructured. It can include some specific charts that are structured. So it's a combination of both structured and unstructured information. So, and what are the advantages of using electronic medical records? The first one is that it's richness. So it has a lot of information. You can collect a lot of information about patients without using a lot of paperwork. And it can have a lot of, millions of patients in it. So which is very good for deep learning tasks. When you just get familiar with the deep learning algorithms, you will see that for training a computer using deep learning models or machine learning techniques, we need a lot of data. So which is great using an EMR because they are very well aligned with using deep learning techniques. And the other one is that this type of data can be used for just studying about a specific individual or studying about the population. So it can be used for multiple purposes. And the other one is that in terms of doing a research project, when you want to do a research project, this could be a byproduct, which means that you don't need to start collecting information for the research because you already have all the information, because you know that when you are doing a research project, you need to have access to data, and most of the time we are using secondary data, which means that the data is already collected. So when we collect the data as EMR records, it's already used as a daily routine. So there is no need for collecting data again and again. So you can have access to multiple data sets very quickly. And this is another advantage of using EMR in medical field. And however, we do have some drawbacks of EMR. Sometimes the quality of the data is questionable because it depends on the person who is collecting the data and putting them in the computer. And it includes sensitive information about patient's health. So we need to just keep the patient's privacy, and we need to be aware of keeping the privacy of the patient and following the ethical steps. And there is sheer scale, which means that we do have a lot of information, we do have a lot of data, which could be complex, and in terms of managing, in terms of cleaning. So this is another drawback of using this type of data. And as you saw, there are many different data types. It could include clinical notes, it could include images, gene information, videos, or any photographs. So there are many different types of data which could be challenging to deal with. So we need some trained staff to deal with this information. And this one, longitudinal complexity, which means that we already have longitudinal information from the patient, which is great for finding the trend of a disease. However, when it comes to working with AI and applying AI techniques to this model, sometimes it makes it more complicated for the model, because we do have some longitudinal information, and if we want to track the disease of the patient or track the progress of a disease, it may cause some challenges for the machine learning or AI models. Any questions from EMR? Okay, quality medical. Okay, someone, just Reza, mentioned that EMR is quality medical services to public. Oh, and one question, is EMR universal or local? What do you think? Yes. Exactly, yes, yeah. For example, like AHS, and we do have something else, yeah. So EMR is something that is defined by the specific region, is not universal, but yeah. And another Elda just mentioned that local depending on the country. Yeah, and the different countries, they have different rules. And so, yeah, USA and Canada use it. We do have a EMR in other countries, as far as I know, but yeah, but the protocol is different. Yeah. So, oh, I'm not sure. Someone is asking, Reza is asking, is any efforts for making it universal? Oh, it depends, because it is something related to patient's information and it's very sensitive. So it cannot be something maybe universal. It's mainly regional. Okay. Okay. Okay, and the next part is about medical imaging, which you also mentioned that diagnostics and medical imaging, you specified it as one of the most, fields in medicine or healthcare that AI can be applied in, which is medical imaging or diagnostics, and it is part of the EMR. It is included in those EMR information. And most of you or all of you should be aware of what medical imaging is. It's the use of advanced imaging modalities such as X-rays, CTs, ultrasounds, and different methods to visualize the internal body structures, and which is great for making diagnoses, for treatment planning, and for monitoring a specific medical condition. And there are different types of medical imaging that exist in the field of medicine, and some of them are very new and recent, and that can be used for studying the health or tracking the health condition of the patients. And we do have, when we are, keep in mind that these disadvantages are mainly defined based on the relationship for AI application. So it's not about all the advantages and disadvantages. There might be another issues with this type of data set, but most of the time the purpose is to see if there are advantages and disadvantages in when applying AI to this type of data. The first advantage of medical imaging is that it has higher diagnostic accuracy. Sometimes when we are looking at an image, we may overlook something, or we may just miss something, which is a very small changes or things which we can use digital imaging to improve the visualization of specific anatomical structures or anything that can be found in the images. So it improved the accuracy of the diagnosis, and definitely by improving the diagnostic accuracy, the treatment planning will improve, because if we can find something specifically using those 3D methods like MRI or CT, we can have more information, more precise information to making a more precise treatment planning. And when we are using medical imaging and this computer-based, it's much easier to share the information, share the images with other people in the healthcare, or retrieve the information. And these new technologies have lower radiation exposure compared to the film-based methods. And finally, these images are very AI friendly, which means that there are many AI models that can be applied to these images and analyze the images. So this is another advantage of medical imaging data. And on the other side, we do have some drawbacks. The first one is that the images, specifically MRI, CT, or other methods, are very high, large in file size, so they are taking up much of space in the memory. So we need to have more powerful computers to keep these images. And for sure, we do have high initial investment, both for having the equipment or for even updating the equipment or monitoring the equipment. We need, it's expensive and we need money. And training and software dependency, which means that we need to have some staff that are aware of how to work with these techniques, and they need to be trained. We do have some image artifacts and errors, sometimes because of the motion of the patient, or some errors that can occur during the, taking the image. And the last one is about privacy and security risk, because we usually use cloud, store these images in a cloud base, and so always there is a risk for breach of data, and if it is not securely managed or if it is not encrypted. So this is another drawback of using medical images. Any questions about medical imaging? Okay. Sure. Oh, of course, yes. We can have a very quick break. 5 minutes? Yeah. Okay. Yeah. Yeah, sounds good. So we are going to have a quick break for 5 minutes, and then we will continue with another types of data. How is it so far? Okay. So I'm going back to the disadvantages one. Okay. Okay. Okay, Dennis, do you have any questions about the disadvantages, or are you good?
That's great. Thank you.
Okay. Just let me know if you have any questions. So we are going to continue with the next type of data and information collected in EMR, which is charting and clinical notes, which is a very common thing that we use in healthcare. And those are part of EMR that are essential for recording patient history, any medical history, dental history, any type of diagnosis, or any proposed treatment planning. And this is part of the EMR system that can capture many information. And one of the recent advancements in this field is using some features that can convert a speech to text. Whenever a clinician is examining the patient, he starts telling whatever he finds, and this is a computer task to convert his voice to text, and there is no need for someone to sit there and just type everything that he is telling. So which is a very great advancement, and it has some for sure advantages and disadvantages, so we will talk in the next few slides. And we do have different type of chartings and clinical notes. Some of them look like something like this. They are very well structured. We do have specific tables, specific sheets that we can just add information like the name of the patient, some demographic information, or something about the health insurance. And sometimes they look like unstructured information that are collected within the notes. So these are different type of clinical chartings and clinical notes that can be used. And we do have some advantages of charting and clinical notes. So first of all, it is part of the EMR. And so this is a standard way of collecting information and data. So it will improve treatment tracking. As we said, that this information includes some longitudinal information about the patient. So we can track the progress of the disease. So we can track the treatment outcome. It is in terms of applying AI, these are because they are digitalized and they are saved in the computer, so it's very much easier to feed them with AI, integrate AI to this type of data compared to, handwritten papers. And so some methods like speech to text improve the efficiency, and it makes it much faster. And another thing is that they are cloud-based most of the time. And if we can use some security management and encryption methods, so we can make sure that there is no, breach of data. And in terms of disadvantages of charting, for sure, we need people who are trained, who know how to work with this type of technology, and we need to adopt these methods. And sometimes when we are using voice-to-text systems, we need to be sure that it is not prone to errors. For example, sometimes when you say something, the computer may convert it to something else. It cannot hear well, so there are some terminology errors. And we do have some ethical issues sometimes, because if we want to share digital records, we need to make sure that we do have the encryption and those security managements properly done. And sometimes there are some errors about inaccurate or incomplete entries. Sometimes, for example, you may have seen that some clinicians use some specific abbreviations when they are putting information or putting data. And when we use those type of information, and it's not the same between different clinics, among different clinical settings, it might be more difficult for the algorithm or AI to detect those specific things. So this is very important to make sure that this information are completely recorded. And here I do have some examples of papers in which AI have been used in medical field and or healthcare, and with some promising results. The first one is about an AI model which was trained on a 3D CBCT chest CT of the patients, and it was published by Ardila et al. In 2019. And the objective was to screen patients based on the lung cancer, and the results showed that the AI model had higher sensitivity and specificity compared to the human expert. Another application of AI for screening a condition was using AI-assisted screening for those oral potentially malignant disorders using some photographs that were taken by a smartphone, and it was nothing, just photographs of the lesion, and it showed a very accurate, very good results based on this, ROC curve and area under curve. You can see that it performed very well in screening patients who are susceptible to having oral cancer. Another application of AI for diagnosis task was published in 2020 by Harman et al. They used artificial intelligence for COVID-19 detection on COVID-19 pneumonia detection on chest CT, and you can see the results. It showed very good sensitivity and specificity, which means that AI was able to make a diagnosis of pneumonia using the CT images, which was faster compared to the clinician and was accurate, comparable to the clinician. And this is another one. Sorry, because I'm a dentist, I included some samples, just one example of the dental field in any of these tasks. So the other one was using AI for detecting caries on this type of radiograph, which is called bite wing radiographs. And they compared combination of AI and human clinician with the human without AI. And as you can see in the results, the red dots refer to the dentist with AI, which is called augmented intelligence, which means that it's not just artificial intelligence. This is the help of the AI and human, both together. So this is the diagnosis made by both of them. And you can see the red dots show higher specificity and higher sensitivity compared to the dentist without AI. So it means that AI can support human clinician decision, and it can improve the diagnosis performance of the human. Okay, so let's see if there is no question. The next two slides, I'm going to wrap it up by talking about main benefits and challenges of integrating AI, because based on the, what we talked about today, we saw that AI has some applications in medical field. It is really great. It is going to improve the diagnosis. It is going to support a clinician decision. But if you want to integrate AI in our clinical practice, what are the benefits and challenges? And the decision depends on you, if you want to integrate it in your practice or not. Well, the main benefits of advantages of using AI, as it is shown in several papers, multiple papers, and you saw just a few examples of those papers, it improves diagnostic precision because it can make some diagnosis, or it can detect something in very early stages that might be overlooked by human. So this is going to improve the diagnosis by the human, and for sure it is going to predict some conditions like the screening papers that we talked about. So it is going to provide you with some predictions about the patient's condition. It's going to improve the diagnosis, and for sure it's going to improve the treatment outcome and the patient outcome. And another advantage is that it improves the patient accessibility, because in some areas which are undeserved the people don't have access to clinician or good clinical care. So there are specific programs that can provide patients with information and with educational materials and to track their health. So which is great for having equity in access to healthcare. And on the other hand, we do have some potential, disadvantages of AI adoption in medicine. The first of all is about data privacy regulation, because when we are dealing with AI, we are doing everything with the computer. And if you want to share data, we need to just make sure that this information are very sensitive and they should be encrypted and be secured in a proper way. And the other one is about the AI bias risk, because we said that the performance of an AI model depends on the quality and quantity of the data. And so if the data provided to the computer is not enough or not prepared in a, correct way, the quality is not good, so we cannot expect a model to provide us with good results. And another problem is with high initial investment. For sure, if we want to apply new techniques, new technology, we need computers that are powerful. They can have good, powerful memories. So all of these need money. And the high cost of having or moving with the technology is another potential drawback of AI adoption in medicine. So before just saying goodbye, can you all please scan this code and provide us with your feedback? So we are going to use your feedback for the future sessions and try to address your expectations of this course.